Alright, time for another draftphysics.com video presentation.
There's no choice. Nature can deal with kinetic energy one way or another, but it cannot finagle momentum. So it must give.
Alright, so Franklin Who has made a video that I wish, this video was real. Okay, that's not a video we should take down. It says the kinetic energy formula is wrong. Draft science was right. So he's not making my arguments. He's not using the logic I've been applying for deliberate reasons. The experiments I've been indicating are probably more likely to get you an accurate result. All of that kind of stuff. And instead he's applying his own reasoning. And this is all stuff that you learn. We live and learn. Okay, so through this process, we've learned some things about how friction isn't even. All right, and everybody sort of has to accept that. And the shape of objects hitting other objects, it makes a difference which shape they are. It won't be linear. It won't be proportional. So there's lots of little things. Okay, quick releases. It's important to have a quick release when you're doing experiments. And he hasn't done any of that, living and learning. And so he's jumping in, and he's jumping in based on something that, it's a painful subject for me. Okay, this whole, you have to lift something 4 times as high in gravity to get twice the velocity. It has to be 4 times higher. Can't go twice as fast unless you lift it 4 times higher. So it doesn't make much sense, right? 4 units of distance, and yet you only get 2 units of velocity. But that is how gravity works, because it does this 1, 3, 5, 7 thing. Okay, in terms of as you increase your speed, you go through the gravity faster and faster, so you cover more space for the same tiny bit of extra energy. So when a meteorite's hurling into the earth from a far distance based on gravitational influences, what it gained in the first foot is just as much energy as it gained in the whole last mile it traveled, because it's just about time in the gravity. Alright, so he's still doing this stupid rolling things down a ramp, and it's better to use a pendulum or something else, because the ramp ends up creating angular momentum, which is also destructive to trying to do this experiment, because that changes your velocity. And more importantly, this is not any way to get to, all you're trying to do is double the velocity. Half the mass, twice the velocity. You're trying to create this 2-to-1 inverse relationship. Okay, something twice as heavy going half the speed, something twice as, half as much going, well, you get me. 5-ton train, 10-ton train. That's all you're trying to do, is create this inverse relationship between mass and velocity. And ramps aren't a great way to do it, frankly. Okay, but anyway, so he's doing what I did. Okay, for 6 hours I was under the delusion the 4 thing didn't exist, and I don't know why that happened, because I knew better, but I did it, and I made a really dumb video. And now he's doing the same thing. He's making a really dumb video, based on something that just isn't true. So we'll play a little bit of this, his reasoning, which is just wrong.
Putting in, I believe, and this is one of my assumptions, is that this corresponds proportionally to how high you put it in. Now, the way I justify that is that if I had something that's going to lift my object, in this case, I have a little car, and if I had a hand crank or a motor,
right? But if you had a spring, or you had a lever, or you had some other device where you could throw the car, guess what? It would only take twice the energy to go twice, get to this height, not 4 times the energy. So if you crank it, yes, here it is. Cranking will take you, say if each increment was a 2 plus 2, you get to 4. You could cut that in half and just have 2 by throwing the car to the height, because then you would have that increase in velocity to a decrease in velocity. You'd have that 3-to-1 relationship that would be inverse to the 1-to-3 relationship that happens when you drop it. So this will not get you twice the velocity. To get twice the velocity going down the ramp, you have to make the ramp 4 times as high. It's in the Mythbusters video. So again, it's like he doesn't even have the context of the Mythbusters video. So I'm just going to go over the some of this stuff and just draw it and just say, you know, these are all the arguments that have been made and understood. You know, and anyone arguing in this context has to deal with these specific things that we've already witnessed. Okay, they're already well-established facts. And stick in that realm instead of whatever this drifting off, you know, doing it some different way that's already been done and shown not to be the best way to do it. I mean, friction isn't even. You can't go based on how far something rolls. So even if you got the right velocities, which you won't get, it doesn't matter how far stuff rolls, because the rolling is not even. Heavy things lose more energy more quickly. So this friction argument I have made over and over and over now, and there's no way to dispute it. It's just an absolute fact. All right, that if I have two vehicles with the same platform and I have one with 2 times the weight on it, all right, this one will dispense its energy more quickly. So if they're both, you know, if I just push them with a certain amount of energy, get them rolling, this one, because of gravity, it weighs more. It will contact the surface more little strings, you could argue, more connection, more electrical connection, more connection to the ground than this one. And the faster and faster I make something move, the less and less contact it'll have with the ground, to a point where, yes, the curvature of the earth will mean it won't touch the ground at all, and there'll be zero friction. So you can understand that the friction is completely dependent on the speed. I'm going to make the speed a little bit less than flying speed. It barely touches the ground, and then barely, you know, I just slow it down a little bit, and I make more and more contact with the ground, and I lose more and more energy faster and faster. So obviously the heavier object loses its energy to friction, okay, much faster than the lighter object. So of course the lighter object on a frictioned surface will go 4 times as far sometimes 5 times as far. All right, but it's not telling you it has more energy. It's telling you it's incurring less friction. And so if we did the experiment, the same experiment from space, okay, you'll get the nice simple relationship. The 2 mass will go this distance, you know, because it's heavier and it's going to have a half the velocity, and the other object will go twice the distance, not 4 times the distance. It won't just keep rolling and all that kind of crap. They're just going to go their distances based on their velocities, because friction, okay, isn't going to consume their energy. And you'll find out that the distance is just 2 to 1, just as the velocity is 2 to 1. All right, so you can't use, you know, a ramp or a pendulum. Like I say, pendulums are better because at least pendulums aren't going to rotate, so they're not going to consume energy, causing wheels to turn and storing the energy in the turn of the wheels. Now, wheels on carts are okay-ish because the car stops because something else hits the surface. But if you allow the round wheel to actually hit the surface, then you're really in trouble, because the angular momentum will be down, right? The rotation is down. When the part that hits the surface will be rotating down. It won't be rotating towards. So that energy will be lost in terms of your linear measurement. You can't measure its linear energy if the measurement is pushing the scale down instead of pushing the scale in. So, I mean, there's just so many of these arguments. All right, so the experiment that started this MV squared over 250 years ago, silly crude experiment. Okay, somebody drops round balls, okay, into clay. All right, and the trick is, if you don't drop them so they go past the halfway point, the fact is that the ones going faster and slower, they'll go in deeper, right? And the deeper the ball goes, the more this surface, okay, the surface pushing this way, is hitting the clay, and the proportion of surface going this way, the flat surface, is less and less. So more and more, so for the one that doesn't penetrate as far, right, just makes a small dimple, versus the one that makes a bigger dimple, you can understand that this one, a higher proportion of its energy is in this flat area, and less of its contact will happen here. And in this case, it's a small amount this way, and much more of the contact with the clay will be pushing in this direction. So you can understand it's exactly inverse. So of course this one, okay, makes a smaller dent in the clay because its energy is pushing this way, where this one will be pushing more this way and this way than that way. Okay, so that's why that experiment fails to get accurate results. And so the Mythbusters did it in a different way, and that one was pretty decisive in terms of the proof it created. All right, so they did do the 4 times. They did have the right angle. They have twice the speed. So this is like comparing a 100 mile an hour and a 50 mile an hour by just dropping a weight. Okay, well, I've got this exactly backwards. No, this is 50 and that's the 100. So the 100 is actually 4 units of height, okay, compared to 1 unit of height here. So that's what they did. So they got the right velocities, and the clay crushed proportional to the speed. So that is, the 100 mile an hour crash was that much, well, the 100 mile an hour is this much, and the 50 mile an hour ends up being twice as big. 2 to 1, and pretty much perfectly 2 to 1. Now when they crashed actual cars into a brick wall, the cars did exactly the same thing. 50 mile an hour crash, this much compression, 100 mile an hour crash, exactly half, twice as much compression. 2 to 1 again. Then Brozo did the experiment with cue balls. Okay, so you have 2 cue balls, a 2 mass one and a 1 mass one. You launch them with the same force by using a lever with a spring on it, so it's exactly the same force that's pushing them. This one goes 11 units of time to travel a course. This one uses 19 units of time. Almost 2 to 1. Lever itself, just a balanced lever. Okay, so I showed on a string, you put 1 mass, 1 unit of distance from the fulcrum. And you put a quarter mass, 4 units. So you have a 4 to 1 relationship. This one goes up and down 4 times. For every unit of distance, this side goes 1. You have 4 units of distance. You have twice 4 times the velocity, right? Yeah. That you'll have over here. So, and it oscillates perfectly. So and it perfectly balances. So so 1 ball out here and 4 here, okay, balance perfectly, demonstrating that they weigh the same, that I couldn't really tell the difference, okay, whether somebody puts this on the lever or they put 4 items right here and I try to feel it on this side. I'm not going to feel the difference because they're going to weigh exactly the same. The weight will feel the same, the pressure will be the same, just demonstrating that this is equal. This does not have 4 times the energy, just as this doesn't have twice the energy. The 10-ton train going 5 miles an hour has the same energy as a 5-ton train going 10 miles an hour. The 5-ton train does not have twice as much energy. It will not do twice as much work. It will not heat twice as much water. It will not do anything twice as much as the 10-ton train. Alright, so that probably covers enough of it. So that's the context. All these arguments have been made for 2 years now, and frankly, again, like I said, Franklin's got this terribly wrong assumption going into the experiment. He's not going to get the right velocities, and so the experiment is garbage. And it would have been garbage anyway, because rolling carts down ramps and then using friction to pull the energy out isn't going to tell you how much, the distance isn't going to tell you how much energy it has, how far it travels, because friction isn't fair. Friction, gravitational friction caused by gravity pushing you into a surface, okay, is just as broken in terms of that 4-to-1 relationship. It hurts the heavy object so much more than it hurts the lighter object. The lighter the object, the less gravitational friction is an issue.
It takes
All right. So yeah, let's finish this a
constant
little bit.
amount of energy for me to raise it up, say, this distance. And then if I were to raise it to twice that distance, I would have to crank that thing twice as long. And if I had to crank it...
Right, but that's only true if you're using a crank. If you're going up one little piece at a time, that's hugely wasteful. So if you just launch the car, you could use half as much energy to get the same result. Because that's exactly what gravity does.
4 times as high, it would take 4 times as amount of energy. So the energy input is going to be proportional to the height.
So it isn't proportional because the velocity proves that. The output velocity for just going twice as high will not be twice as fast. Not even close. So, fail. You're wrong. It's a wrong premise. The logic is broken. It doesn't work that way. Alright, so I guess I'll watch the video and see how bad this gets. But there's no point, like I said, it's just, the whole thing is garbage. And he already did this, and I told him, you can't do that. You can't, this experiment will not work. You can't do this to prove the point, because it's just wrong. I'm sorry, it's just wrong, okay? It's not twice the velocity. And if you're not going to produce twice the velocity, you're not comparing two things with the same momentum. Shit. Yeah, well, that didn't last long. He said something here amazing. So just more, man, come on. You got to do better than this. I'm sorry, this is just almost stupid.
By the height. Now, as a practical matter, I don't want to just drop my car and let it hit the floor. And plus, there's no way for me to measure how much energy is in that car if I did that, right?
So of course there is. You just put a scale under it. That's all. You're measuring the energy. That's what scales do. Scales measure how much energy something has, how much weight it has. So you want to see how heavy the fish is, so you take a spring and you just let it hang from the spring, see how much it pulls the spring. Same difference here. You're just measuring how much impact weight it has. And that's telling you exactly how much energy it has. So it would work just fine. Just put a scale under it and drop it from 4 times as high. It'll be going twice as fast, and it will give you an impact impression, an instantaneous weight. Now, so clearly it's a little tricky measuring instantaneous weight. That is the most expansion of a spring. You have to use an analog scale, not a digital scale. Digital scales won't give you that information, but an analog scale will. A spring will. The spring will have a maximum compression. You can just mark that on the video, boom, and you'll know exactly how much energy the car hit with. The spring will collect it all. Just like it collects it all in your bathroom, or it collects it. Springs work. Okay, it will collect the energy. So, that's just wrong to say there's no way to do it. It's pretty easy to do. And the fact that actual physics hasn't done any of these experiments, you actually can't find any experiments where a physicist is just dropping objects from different heights onto springs, onto scales. There's no video of it. And the reason why there's no video of it, because it clearly demonstrates that the only thing happening is momentum. There's just absolutely no evidence of this kinetic energy existing. Yeah, so I guess I'll pause. I suppose I should just play the video, because you just keep saying stuff and you're just like, oh, big mistake again. So you really, all this stuff that he hasn't learned through these 2 years of my, obviously, conversations. And, so he keeps making just, glaring mistakes. They're glaring now. They're so obvious to people who have listened to all these videos. This is a glaring mistake.
And the presumption is that as the car rolls, there's going to be rolling resistance. And assuming that the rolling resistance is constant.
So again, why would you assume that? Why would you assume something that's twice as heavy has the same friction as something lighter? When every bit of our life experience indicates that no, when something's stuck on the ground, it's harder to initiate movement in the heavier object than it is the lighter object, because you have to break the friction, and you have more friction to break. So that's just telling you right away that this friction thing, to break the friction, to break the hold the friction has, that you actually have to waste some energy to get something even started. So fail, frankly. All right, we'll play a little more of this just to see, because I keep not getting anywhere.
And that's another assumption we will have to and do test. The distance that this thing rolls is going to be proportional to the kinetic energy.
So whatever. There's no kinetic energy is my whole point. So why even talk about proportional to the kinetic energy? You're arguing that it's supposed to be proportional to its momentum. The argument is you're creating two objects with the same momentum, and now we're going to try to explain how one of them has twice as much kinetic energy. So 5-ton train, 10 miles an hour. Same momentum as 10-ton train going 5 miles an hour. Now, how do you explain how one of them has twice as much energy, can do twice as much work in the universe? How one of them will decisively win a tug of war? No, none of that will happen, demonstrating there's no such thing as kinetic energy.
Kinetic energy is equal to the distance. Once again, presuming not less.
So yeah, presuming nothing. It's nonsense. So do the distance in space, and the thing moving twice as fast will go exactly twice the distance. It won't go 4 times further because it won't have 4 times the energy, and none of that crap is true. All it will be is a half mass moving twice as fast, and the distance will exactly equal that outcome, and there'll be no evidence of any kinetic energy.
As Gary says, friction lies. Okay. But so we have to look at that and make sure that friction is not lying to us.
Oh, okay. So, you're not going to do that, okay? That ain't going to happen. It's just stupid. What, you're going to demonstrate that friction, that when a 16-pound ball hits bowling pins, it gives each pin the same amount of energy that an 8-pound ball going twice as fast gives the pins? When anybody logical can know if something's going twice as fast and it hits a pin, the pin's going to leave with much more velocity than when the 16-pound ball hits it. The 16-pound ball going 8 miles an hour. The pin can only leave at a little over 8 miles an hour from the 16-pound ball. The pin leaving from the 8-pound ball going 16 miles an hour can leave at 16 miles an hour. So obviously the pin has a constant mass, and you're doubling its velocity. Obviously the first pin it hits, the 8-pound ball gave it twice as much energy as the 16-pound ball gave it. But the point is later, okay, after the 8-pound ball has run out of energy, the 16-pound ball will now be giving twice as much energy to every pin.
But let me show you a video about my new setup here, and I'll show you what is new and improved. Okay.
All right. So there's obviously it's the same exact diagram, so it's the same exact logic. You're not doing the 4 times thing to double the velocity. You're not going to be doubling the velocity, so the whole thing is just a waste of time. So now I'll pause. All right. So he has some of his data here, but you can't read any of it. So I think what he's doing is he's doing frame rates to create an understanding of the velocity coming off the ramp, and then comparing that, I think, to how far the car travels, right? I don't know how far it ends up going. All right. And again, my argument would be that's useless information, because how far it's going to go is going to depend. It's not going to be proportional. The faster it's going, the less friction, the less energy it will give away to friction, and it has to wait until it's gone 3 times of the distance. So if there's the total distance is this much distance, 2/3 of the distance you'll lose as much to friction as you will in the last one. So as soon as it gets to the same speed that the other car going half the speed is going, right, this one will incur as much friction as this one in this little tiny bit of distance here. And this distance will be the same amount of friction as that little tiny bit. So that has to be understood, that it's not proportional and it's not linear. It's because of gravity. Now it's even worse when you have 2 opposite weighted cars. So he's not using the 2-to-1, 10-ton train versus 5-ton train comparison. So obviously the friction differential is just about speed when it's the same mass. But when you also invert the masses to the speed, then you double the effects of this frictional unfairness, because now the heavier car obviously has more contact and therefore loses more to friction just because of the contact. So a lot of physics being overlooked here, being given short shrift. So he does this experiment too, okay, which is also just hugely flawed and not very useful because the premises are wrong.
Video. Okay, there's this video here. And so I've got the treadmill here, and what I have is I have my car connected to a string, and I've got it connected to a very sensitive gram scale.
All right, so it's a very sensitive gram scale, you say, but it's not analog, it's digital. So how do you know it can measure impulse? That is energy that doesn't have a durability. It can't. There's no reason. Digital scales average. That's what they're made to do. They're not made to give you how much weight am I feeling in this millisecond. That's not what they do. They take it over a whole period of time and take a bunch of measurements and then average the measurements. So it's not going to give you an accurate reading. And the same problem exists in terms of all you're doing is saying I'm changing how much the friction is moving. That is how much the surface is moving against the car. The car is not changing weight. So obviously at the higher speed it's going to have less contact because it's going to bounce.
So when I put the car on the treadmill, I can measure what the gram force is. And for this particular experiment, it was about 5 grams. And I'll tell you that the scale bounces wildly when you're doing this experiment, so it's really hard to get a straight number. But in spite of those challenges, I tried it at 1 mile.
Yeah, so you really should do it with a spring. And then, the fact is it's not duplicating what happens in the real world, in the sense the real world experiment is about masses, different masses. And that the heavier object is obviously at the slower speed is going to lose more to friction. It's going to weigh more. You're going to detect more grams of weight, kind of obviously. So it's not useful evidence. Again, even though he's arguing it supports my conclusion, I can't support how he got to the conclusion because it's not right. Alright, well this is a bizarre and interesting bit where he's now conceding the gravity argument, yet he just ignored it on his ramp. So again, it's really hard. You can't see his data here. I don't see any point in, like, say you're doing frame rates and measuring the speed of a car on a just trying to discern its motion. Okay, you're just trying to say what's its velocity, and you're counting the frames. Well, obviously something going twice as fast will use up twice the distance, half the distance, and something going half the speed will be twice the distance because it has to be, right? There's that doesn't prove anything, right? They're still arguing that's a given. It's impossible for you to even measure the velocity if that weren't true. If it weren't true that 100 miles will go this far in the same amount of time as 50 miles will go this amount of time, in the same amount of time, this amount of distance. It'll always be twice the distance in twice the time in the same time. Half the speed in the same time will be twice the distance. Has to be. So I mean, that doesn't prove anything because that's true for all of these experiments. I mean, you can't get away from that. That's impossible for that not to be true. They're saying that in spite of what it looks like, that they have the same energy, somehow the one going twice as fast will in fact leave, or like if it was a lever. The lever's showing it, okay? The lever's doing it, all right? I have the fulcrum here, and I have the 2 mass here, and I have a 1 mass twice the distance out here. It's moving twice as fast, all right? And it's oscillating. And then I stop it from oscillating, and the atoms fly off. They're arguing that even though it's going twice as fast, it'll only leave going 1.4. So even though it has to go twice as fast, it'll only leave at 1.4. That's their argument. So I'm just saying that's how silly this whole thing is. But obviously, if it's going half as fast, and you're measuring it right, of course it's got to be twice the distance. It can't be 4 times the distance. It can't go more distance because you're measuring its velocity based on how far it goes. in a specific amount of time. So it's not telling you anything. So anyway, here he goes with the gravity thing.
Of an object is proportional to its velocity, not velocity squared. Now, one interesting factor is that, say, in the ball drop experiment, so, Gary mentioned that, the velocity doubles when you increase the height by 4, because there's a standard acceleration formula. And that's what it tells you, that in order to get twice the velocity, you have to be 4 times the distance. But
4 times the height. 4 times the height. What you just said in your video where you went twice as high. That ain't right. Twice as high isn't going to be twice as fast. It's not going to be twice as much energy.
Another curious thing I found is that the acceleration formula itself doesn't seem to work.
Well, of course, the acceleration formula is where they just took something, they took that gravitational formula that says something simple like it's 9.8 meters per second, and they said, let's write that as seconds squared. It's seconds per second. It means it's seconds times a second. How many seconds was it? So it's a second times how many seconds. And they turn that into seconds squared. I mean, I'm just saying it's kind of obvious that, no, I could be 3 seconds in the gravity. I could be 10 seconds. I could be 500 seconds. It's not seconds squared. It's the seconds times how the 9.8. 9.8 times how many seconds. It's not seconds squared. So obviously their acceleration formula is where they broke the acceleration formula to create the work equation to make all of this tie together. Because obviously the mv squared thing was this aberrant, strange bizarreness, and they had to somehow make all the other stuff fit with that broken, bizarre pile of crap. And break, conservation of energy in the process. And then pretend they didn't, when it's obvious they did. Levers break conservation of momentum. By their definition.
Because in my data here, I had the initial position at 5, but when it doubled to 10, I was actually only at the third, only 3 times as high, produced a doubling of the velocity. I mean, you got...
Okay, well, obviously you did something wrong. No, then we're talking about the angular momentum. But I'm just saying that there's no way you could go, there's go 1/3 the distance. There's no way you could get from the Galilean relationship. You can't create free energy. All right, so there's just no way to break that. So to say you went 3 times higher and got twice the velocity, well, obviously you did something wrong. And it all might have to do with what you were showing before, which is the friction problem, getting the car started. So when you have a little bit of energy, it's hard to get the car rolling, and that's a huge disproportion. So when you're going to move the car fast, that initial breaking the friction is a tiny fraction of the total energy. But when you're using a smaller amount of energy, the amount of braking, break the friction, getting the car rolling, okay, that's a higher percentage of the total energy. So that might be why your reading came out that way. Because the slow-moving car used up much more of a percentage of its energy breaking the friction and causing the angular momentum in the wheels.
4 times. We're talking about 2.3 to 2.8 times faster, right? So it's going faster than twice as much.
Okay, well, I'm sorry. You can't do that. That's free energy too. So wrong, can't be. You made a mistake.
Right? And so these two kind of balance each other out because and I think when they did like the lead ball, the ball against the clay, they probably didn't have.
All right, so I've already been through this clay thing so much. It has to do with the fact that you're dropping a shaped object. If it didn't have a point to it, so to speak. I mean, round is it's a wedge. Round is the same thing as dropping a triangle in a sense. Okay, it's the triangle is exactly the opposite circumstance where there's no flat part at the bottom and then it gets angular at the sides. But I'm just saying it's just as much of a cheat. And you understand that if I drop blunt object and pointed object, I'm going to get different results. And if I penetrate the further I penetrate, the more and more you're pushing clay to the side rather than pushing clay down. And that's pretty obvious. So again, it's more work. The first initial impact with the clay is more work because there's more flat surface hitting the clay. But once you start penetrating the clay, then you're doing more work pushing it sideways. More surface is pushing the clay sideways than surface is pushing the clay down. And that's the advantage the deeper you go. So if you make both of these balls fall at a velocity high enough to get halfway into the clay, then you'll have a more even experiment. But if you do it with one ball that only goes in 1/4 and the other ball goes in something less than a half, then you're going to get unfair results. The one that goes into the clay less spent more of its time pushing clay down than pushing clay sideways, and the one that went deeper spent more time pushing clay sideways than pushing clay down. And it's a huge disadvantage.
Sophisticated high-speed cameras that they could, objectively measure. What they assumed, just like we assumed the kinetic energy formula is correct, they assumed that the acceleration in gravity formula was correct. And curiously,
the acceleration in gravity formula is correct. I mean, that one's been done over and over again. You're not going to change that. So again, this is a scale argument. You could just prove it with a scale. I did it, okay? Drop something from 1 centimeter. You'll see that its weight doubles. An analog scale. Use an analog scale, spring scale. I have one here? No. Where the hell did I put it? Well, anyway, guess it's still on the porch. Then drop it from 4 centimeters. It doubles the weight again. Then drop it from 16 centimeters. It doubles the weight again. So I've proven Galileo correct. So to argue that you're going to demonstrate that theory to be incorrect, good fucking luck, because I don't think that's going to happen.
No, it doesn't seem to be correct. I did try to do some direct ball drop experiments. And
well, there you go. Okay, so apparently those are the things. You're saying you're doing this very scientifically and being very careful and all this kind of crap, but it doesn't look like you're being all that careful.
These are even harder to do because even using a high-speed camera at 90 frames per second, the ball, when it goes to the frame, looks like a big old blur. And yeah, it makes it hard to measure. But
right, you don't need to measure it. All you need to do is measure the distance you drop it and then take a good picture of what the scale does. And that's all you need.
I did get some similar results. And I got some conflicting results initially, but eventually when in my final setup, which I have the data over here, found that when you're at 4 times the height, you're actually going something like 2.8 times as fast.
All right. Yeah, sorry. Well, I didn't notice any of that. So, maybe that can be your own thing to say you're proven. But don't you see how I think you're just injecting noise now? I mean, to argue with something that well established, in terms of all all the space science that's dependent on understanding this 1, 3, 5, 7 ratio. I mean, all this stuff is so well tested. I just don't know how you're going to get away with this. That one you're going to say is wrong. I mean, Leibniz creating mv squared, okay, that's a target, okay, because he was a nut, frankly. And he had absolutely no physical evidence for his argument. He didn't make a logical argument, explain how this made any sense, okay. He just stated that, hey, you people believe in free energy because kinetic energy is conserved. And then everybody just said back to him, no, okay, our energy is conserved and all the experiments show our energy to be conserved and your wacky theory creates free energy. They talked about levers and they pointed out how do levers work then? Where's the kinetic energy in a lever? Because it don't work. Levers convert momentum. 100% of the momentum is conserved. The bullet doesn't leave with 2,000 joules of energy and the gun's recoil is 2. No, it's equal and opposite. Okay, the gun has as much energy, 1,000 atoms moving 1,000 times slower. Yeah, it's that simple. Same energy.
So the thing is that they thought the ball drop demonstrated 1/2 mv squared because they thought that at 4 times the height, it generated a hole which is 4 times as big.
Look, again, you're arguing something. I don't know why you're doing this, okay? I could just show you the Mythbusters video. I mean, they were quite convinced it was twice the velocity. I mean, yeah, there's not enough good video in it to do a frame rate thing, but it's twice the frickin' velocity. 4 times the height for twice the velocity. It works.
But But the thing is like, duh, because you just put in 4 times the amount of energy by lifting it up to that, so you would totally expect.
Okay, so he's just going to try to rationalize again. This is the whole problem. This is where it started 300 years ago, okay? This is it. Everybody thinks gravity is forces. All the other forces are just like gravity. All impacts, all things banging into each other, everything is just gravity. No, gravity is not the only way two things interact in the universe, is because one's being pushed by a gravitational acceleration. This is only something gravity does because of the way gravity functions, because it's a constant force that's not in contact. Okay, it's in contact with every single atom in the object it's moving, and every single atom is collecting the increase in the velocity. And again, it increases the speed. The amount of speed increase here will be the same as the speed increase here. And then the speed increase here will be the same. These units of time will be the same amount of increase in speed. And obviously when it's going faster and faster, it's increasing in speed, tiny little amount compared to its actual already gotten motion. When you're going 10,000 miles an hour towards the Earth, the amount of energy you're collecting from gravity is tiny. Okay, compared to the energy you already have. The 9.8 meters per second is almost meaningless because it'll take you 2 seconds to travel, 100,000 miles. Well, not that much, but you can cover a great distance because of your high velocity. And in that huge, giant distance, you'll gain a tiny, tiny, tiny extra little push.
That it's going to just put the dent in, it's going to be 4 times as large, right?
Wrong. I mean, twice the velocity. It's only twice the time in the gravity. So if you understand gravity as a push force, you can understand, well, it's only pushing for 2 seconds, right? It's not 4 seconds. So one object takes 1 second to do this. It only takes 2 seconds to do 4 times as much. Okay, so you can understand if you're collecting the push, if you're only in the push 2 seconds, you can only collect twice as much.
You don't need 1/2 mv squared to explain that. And if they had actually measured the actual velocity of the ball when it hit the plate, they would find that it was actually going something at like 2.8.
All right. Well, you're wrong. They did these experiments. Galileo. I mean, it's Descartes, Newton. They all did these experiments. So challenging those experiments and that conclusion, I just think there's so many ways that's already been proven. All the pendulum experiments, then we get into the whole, the Dutch guy, Huygens, did a ton of. I mean, the guy built clocks. And the whole world was obsessed with clocks at this time and pendulums. So I mean, it was a huge subject. Everybody was trying to make ones that could be upside down and do all kinds of things. Connecting the pendulums to springs and all kinds of ideas. So this was already known stuff. You're not going to get around it. And yes, levers behave different. Levers are doing the conversion. So you get to see exactly what the real world is, which is twice the velocity, okay? Twice the distance in the lever. But yes, if you're dependent on gravity, you're going to have to go 4 times the distance.
Times as fast and not 2 times as fast. So that ball drop experiment really didn't confirm the kinetic energy formula, because you have to measure the freaking velocity in order to do that, right? You have to confirm the velocity at impact time. I'm sure that they had no way of doing that without.
Okay, I know, but they've had plenty of ways of doing that in the last. Well, even Galileo has a way of doing it. He made the ramp longer, and he put little bells on it, and he figured out how fast it was going by how often it rang the bell. So I mean, come on. If the bell rings ding ding and the bell rings ding ding, you can tell the difference between those two things. You can tell when the tone is twice as fast, when the beat is twice as fast, or when the beat is 3 times as fast, or the beat is 4 times as fast. You can tell those things. So, and that's 300 years ago.
High-speed electronic cameras.
400.
Okay, but I have high-speed electronic cameras. I have access to the internet.
Yes, but it doesn't mean that you've done the best you could have done. And sorry, I mean, there's, sorry, this isn't good enough.
I have things that people 100 years ago would never dream of having, just sitting in their house. But yeah, I know the results here are extremely controversial. I know that.
Yeah, I wish, I mean, I wish I could take this serious and say, hey, great, I got an ally. But you're an ally for the wrong reason. The logic doesn't work. It's false logic, and so you haven't done the right experiment the right way.
My mainstream friends are all going to say this guy is crazy, but if you think I am,
Yeah, whatever. I mean, what use is this? Yeah, I'm crazy because I don't believe there's whatever, a time dimension, and I don't believe there's some other form of energy besides mass is moving. If there's not a mass moving, where's the energy? How can something have more energy merely because it's moving faster? 4 times the energy. It's not proportional to its mass times its velocity. Where is there any other source of motion in the universe besides things that have mass and things that have velocity? There's nothing else but bowling balls and bowling pins. How do I make the bowling ball create twice as many pin drops? I can't do that. Same momentum, same amount of pins moving a distance, period, a velocity. It always just converts into mass and velocity and mass and velocity. Mass and velocity in, mass and velocity out. Has to be conserved. Oh, I'm a crazy person. Yeah, fuck you, I'm crazy.
then I challenge you to prove that I am wrong. And you do that.
Okay, yeah, well, the challenge is pretty easy to meet because, yes, you didn't establish this inverse relationship that reveals the kinetic energy conundrum. The kinetic energy conundrum is shown when you change the mass. You can't really show it without changing the mass.
By repeating this experiment and seeing whether you get the same results. That is a primary cornerstone of proper scientific procedure. Is that one guy does an experiment, the next step is another guy does an experiment, see whether he gets the same result.
Yeah, well, the point is these other guys have done the experiment. So I did do this rolling little ball bearing experiment, okay, and I came up pretty close. I mean, it wasn't 2 to 1 the way it should have been. It was 2 to 8.7 or something. Because how you launch 2 balls is going to fuck up the experiment a little bit. Is it's not going to launch exactly the same. The twice as massive object isn't going to get launched exactly the same as the half mass, because it's hard to shape things 2 identical ways and have one weigh twice as much as the other unless you use titanium and copper or something. Blah 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 blah.
Or if you think my analysis is wrong, show that my analysis is wrong. For example,
well, both. Your theory's wrong, your analysis is wrong, and the mechanics of your experiments is too rickety.
Show that the frictional resistance of some object like this toy car does vary with the velocity in such a way that it completely cancels out the v squared formula in terms of.
Again, you're really not going to get to the flaw in the kinetic energy formula. You're not going to reveal the flaw unless you start changing the mass and velocity. You can't have an object of the same mass and do the experiments because it's not going to reveal the kinetic energy BS as easy as it would be to use different masses. I mean, clearly, twice the velocity doesn't mean something has 4 times the impact power. So, I mean, in that sense, it's pretty easy to prove that, you shoot an arrow twice as fast, it doesn't go 4 times further into the animal or something. I mean, those are things people already realize. Velocity, velocities of bullets and stuff. They don't find any ballistics that reveal this for twice the amount of energy kind of nonsense. I mean, 4 times the energy. Nobody has found it to take 4 times the fuel to go twice as fast. So you could do an experiment in your Corvette. You could just, drive it at 30 and then drive it at 60 and demonstrate that, you didn't use 4 times more fuel to go 60 miles an hour.
Into envy, right? But I'm probably more convinced that the kinetic energy formula is in fact mv, which is what is commonly known as momentum. And as Gary points out, historically, Newton, we love Newtonian mechanics. Newton apparently thought that kinetic energy was mv as well, and apparently
it's not apparent. He directly opposed Leibniz's nonsense. So he was a direct opposition to this silly, fucktarded notion. And he didn't argue very aggressively because guess what? He didn't have to. Everybody agreed with him that Leibniz was being an asshole. Frankly, nobody believed Leibniz. Leibniz died absolutely vacant. Okay, he had no scientific reputation left at all. Nobody showed up for the funeral. Nobody even would pay for his funeral. All right, that's how bad his reputation was. And all of this was resurrected, okay, 20 years after his death. This crap was dug up, this zombie theory, and promoted with these silly little clay experiments. And they got away with this carnival Barker bullshit and this gimmick, this clay gimmick, and fooled everybody. And that's all that happened. There's no other experimental evidence. Besides those stupid clay experiments, there's absolutely no physical experimental evidence demonstrating any of this stupid fucking magical kinetic energy bullshit. That's the historical facts.
If what Gary says is true, that if you are doing something actually practical, like trying to put a spaceship in orbit or maneuver something, you have to use MV and not 1/2 MV squared in order. So NASA uses MV, right?
Yeah, so why don't you show those kind of experiments? Why don't you just use that as the argument? If I'm in space navigating and I throw 2 liters out one side of my ship, at 1,000 1,000th of the velocity, I throw a dime out the other side. The fact is, my ship's going to keep going straight. Because the fact is, I've thrown the same amount of energy out one side that I threw out the other side. All right, and the 2 pushes are going to be exactly the same. And they're just going to make me go this way and then back this way. So I'm just going to be back to where I was. And that's the way it's going to work in space. And that's the truth. Because the dime doesn't have 1,000 times more energy. That's what they say. They say the dime has 1,000 times more energy. That I should go radically in this direction. Because I threw a dime out the window over here. The theory gets more and more preposterous the faster, the higher and higher the velocity. The more you inverse the big M, little v, and you change it to big V, little m. The more you do that, the smaller you make the m and the bigger you make the v, the more insane the disproportion gets. And you're talking thousands or tens of thousands of times more energy than the truth says.
If they did, they might find that there's a problem. I mean, but in most cases, I'm thinking that the fact that this formula is not true doesn't make a heck of a lot of difference in most people's lives, right? Not unless you're trying to design some sort of machine. For example, I don't know, maybe you're trying to.
So it'll make a huge difference to physics. It blows up all particle physics. So all of their Dirac equations, all of this crap that invented neutrinos and antiparticles and all of that crap goes away because all of that crap only exists because of this stupid squared velocity function. Take the squared velocity out of the mathematics and they are done making all their 400 different wacky particles. All of that game is over.
Punch a hole in some thickness of material, and so you have electron punch, and then you figure, oh, well, I want to go punch something that's 4 times as thick, so I'll just dial my punch here to double the velocity, right? And then when I do that, I find out, no, that's not enough. It's not going to work. You have to dial it up like 2.8, and then it has enough velocity to actually punch through, because that's the speed you need that you would get if you had actually 4 times the energy, right?
Whatever this, I don't know what he's still trying to defend some new number, some new wacky number. There's no point in arguing about how you penetrate a piece of leather or how you do this or that, because as I've illustrated with the board, okay, the piece of wood, I just have a plank, a piece of wood, 1 inch thick, 1/2 inch thick, and the fact is, depending on how I put the energy in, I'll get completely different results. Completely different. The board splits in half and flies through the air, versus it just sits there and moves a little and vibrates. Huge difference because of how the energy connects. Just like the same thing with voltage, right? If I want to connect 2 wires and I connect them really slowly with a high amperage, the wires all melt, they do all kinds of crap. But if I connect them quickly, no harm, no foul at all. So come on. There's no point in saying, what does it look like? What does the energy make the thing look like? Okay, because obviously it's like even melting ice or something, right? I mean, at one temperature, it's like melting hardly at all. And I just go one more degree and it melts 4 times faster or 10 times faster. Because, yeah, it's always this tipping point kind of arguments. There's a point where you reach and then the whole thing just falls apart. It fractures. It's like breaking a piece of glass. You could punch it and punch it and punch it and punch it and punch it. All of a sudden it breaks. Huge giant difference between 60 pounds of pressure and 61 pounds of pressure, right? 60 pounds, nothing happens. 61 pounds, everything happens. You don't draw some stupid conclusion from that. You don't say that 61 pounds is 1,000,000 times more energy because I got 1,000,000 times more pieces of glass.
Energy. But it is shocking that things like possibly the acceleration of gravity formula is wrong, as a corollary to why the kinetic energy formula is wrong, and how our belief in...
Jesus, no. The kinetic energy formula wouldn't even be proposed if it wasn't for that 4-to-1 relationship. So again, that's the whole source of the squared function, because we're right back to inverse square law. Okay, and why they have a squared function, because that's how gravity works. Okay, 1, 4, 16, blah, 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 square function. 4 times.
Either or both of these, kind of misled us to think that. So, if you made it this far in the video, I hope I've convinced you through experiments in my MIT.
Yeah, we've already been through all this experiment thing, and the experiments have to be done so much better than this, because they're so easy to fudge. So it's really nice to do. I almost went to MIT, almost. I mean, they weren't going to let me in without an interview, and so I'd have to go there and try to talk them into it and all that kind of crap. So I wasn't like an automatic inner. But the truth is, they were almost 3 times as expensive as LSU. So, blah, blah, blah.
That the most beloved formula in physics is in fact wrong. And once again, you think I'm wrong?
Okay, so beloved formula, I don't know if that's true. It's just really old and really dumb, and that's the funny part. It's really old, really stupid, created by a kook. It just has a horrible, disgustingly horrible history of not really good evidence and people believing out of faith and out of confusion, rather than because it made good scientific sense. It never made good scientific sense. It breaks all of Newton's mechanics that Newton so successfully did all this predicting. If Newton was using mv squared, he wouldn't have done much successful predicting.
Prove it. Do another experiment to prove it, or show me what was wrong with my experiment. Once again, this is now the...
That's fairly easy to do, but you didn't even show us data we could actually see, so we don't even know exactly what you measured. Did you measure how far the cars rolled? Or did you just measure their velocity by measuring how, by counting frames, which is automatically going to be 2-to-1?
Only experiment on the internet, on YouTube, which attempts to directly measure this thing. You show me any other experiment which directly tries to measure the thing and comes up with some mechanism for measuring the amount of kinetic energy in a moving object. That's what you...
Well, I'm just, obviously we've been looking for those for 2 years, and so Brozo's done a bunch of conflicting experiments, but as I point out, the pool ball one's pretty obvious, and the Mythbuster experiment with the crushed cars, pretty decisive piece of evidence that there's no kinetic energy, even though they couldn't even figure out that's the myth they busted. They didn't even recognize that they pretty decisively busted the myth of kinetic energy. Because they were afraid to say it. They're so afraid to say something because they know, they can't challenge that. That's one of the religious icons.
You'd have to show me that, I'm wrong versus the kinetic energy formula. So good luck to everyone. And this just all goes to show you that we cannot rely on using math. So, for example, if you went on the internet and you Google, how to prove the kinetic energy formula.
Well, it doesn't really matter, right? Because then that's also, and you can't rely on experimental evidence either, because as I demonstrated, Lewin faked his experiment. And you can find it all over the place where they talk about braking distance. And then when you actually research all of those papers on braking distance, nobody actually did the fucking experiment. They're all simulations. They're all computer simulations. I mean, garbage in, garbage out, of course. I mean, what a ripoff. So no one's actually done any of these physical experiments. And that's the big joke here. They haven't repeated the Eddington experiment. I mean, the whole fucking science is crap. They haven't tested any of these fundamental assumptions.
What you end up finding is just a bunch of videos that like derive the kinetic energy formula from like the work formula. They all look like stuff like this. Kinetic energy. And it's
yeah, you don't have to tell me. And then half of them are in Hindi now, so you can't even you can't understand the damn videos.
About solving equations and stuff like that, but no actual experiments. And so that is what I am justifying by making this video, which is an actual physical experiment. All right?
That is a shitty one. Sorry. I mean, it's like I said, we have a bunch of brozo experiments, garbage. My own experiment's a little bit lazy and sloppy. But, there's got to be better experiments done than this. Not nearly good enough.
If you're interested in any of my data, any other information, please leave it in the comments, and we'll see if we can get this all figured out.
Yeah, go ahead, post your data somewhere so we can at least see what you measured. Thank you. That would help. Did you measure the distance they rolled? Because if you're measuring rolling distance, yeah, that's not going to work. All right. So, I think that's enough. And certainly, if you're, if you're measuring, he's talking about measuring the velocity based on the frame rate, then why are you worrying how high it is on a ramp? Because you're measuring the velocity. So if you're actually saying that something with twice the velocity only rolled twice as far, I don't know. I mean, that would be very interesting to me. Okay. But I would have the expectation that it would roll more than twice as far. Based on the simple logic, again, that the slower you're going, you're doing the gravity thing again. In the first second falling, you do, one tiny bit of distance, and then the second unit of falling distance, you do a huge amount of distance. The same thing slowing down, going opposite. You lose velocity very slowly in the first pile of time, and then you lose a lot of velocity in the second pile of time. Alright, so till the next time and such and so forth and whatnot. I wish it was good news, but it's really not. I don't need to be right for the wrong reasons. I'll be right for the right reasons. Thank you very much. So, this has been a draftphysics.com video presentation. I guess I'll put it on YouTube because I guess he still doesn't really get that I put videos on the website because Google and YouTube are evil corporations. You might know about evil corporations. I think you basically did all this work for Microsoft and they probably never compensated you for it, right? They just kind of stole your intellectual property. Anyway, till the next time and such.